Hello, everybody. It's Mr. Trochet, and we are going to be talking about 6.2.3. How can I record it? Basically, how can we record our work? Because I know that some of us have trouble showing our work and recording our work, and this is a perfect lesson for us to kind of talk about the idea of showing work, why we show our work, the reasons behind it, and also how to. So we're going to go ahead and we're going to as it says, you will continue to improve your skills of simplifying and solving more complex equations. And we want to make sure we answer these questions today. How can I record the steps I use to solve? And then also, how can I record what is on the equation mat after each step? So let's go ahead and get started here. So here we have Gene and Aiden. They were using algebra tiles to solve an equation. Aiden was called away. Help Gene finish by completing the table below. And you can also click on this little thing here. I'm going to put this in our altitude card as well, and go ahead and just start working on this as such. So the first thing here is we know, dismiss. We know that we have different ways of doing this, but the steps taken are basically the written steps that we are doing. And so if we follow those written steps, we can show our steps on both sides of the mat here. So let's take a look for here. We have mat A and mat B. The first thing we have is our original equation. This is what's given to us. So you always want to rewrite the equation, all right? So make sure you rewrite the equation, all right? That's the thing we need to do, all right? Second thing, here's our first step. Second part, first step, use the distributive property. So in order for us to do that, that is talking about this right here. So we got to distribute here and distribute there. So even though this is what's already been done, this is the next step we take, and then we want to rewrite it on this line. So we can rewrite 2x plus, and then we got 2 times 2x, which is going to be 4x. And then 2 times 1 is going to be positive 2, plus negative 3x, plus negative 6. And then I don't even do anything here necessarily. So I'm going to go ahead and rewrite this expression as such. And then the second thing here is I'm going to use this purplish color. We have 3x plus negative 4 and 5x plus 8. How did we get all the way here? Well, the first thing here is 3x. How did we get 3x? Well, we have these two terms and this term. And what we're going to do is we are going to combine to equal that. We are going to combine like terms. And then let's take a look at the light blue here. So I'm going to take this term, and I'm going to take this term, and that's going to give me that term there. Same thing on the other side. Let's go ahead and take this 5x, which is going to be 4x, and this x right here. So that's going to give us this 5x right there. And you don't have to do the arrows. I'm just showing you that's how they got it. They combined this term and this term here. And then they also have positive negative 3. Well, that's kind of nice. It cancels each other out right there. So we're left with positive 8. So this positive 8 is right there. And we're going to call this combine like terms. And that's what you can do. So combine all your x's together, and then combine all your numbers together. That's what we're going to be doing today. Next, we have subtract 3x from both sides. Well, that's really easy. So how do we do that? Well, I'm going to subtract 3x underneath it. Subtract 3x underneath it. And that is actually going to cancel out. So I'm left with a negative 4. And then I'm left with 2x plus 8. And as you notice, I wrote underneath the x's there on both sides. And that's what we want to do. Show what we're doing. We're subtracting 3x on both sides. Show it on both sides. And then here we have negative 4 and 2x plus 8. What did we get here? Well, we have a 2x here. So we just brought that down. But how did we get from negative 4 to negative 12? Well, you got rid of an 8 here. So you subtract 8 from both sides. And I'm going to subtract 8 on both sides, which is basically like adding negatives on that left side. So we're subtracting from both sides, but it's kind of like adding negatives too. So we're going to say subtract, move this over here. subtract 8 from both sides. All right, and move that up here. And so then we have 2x and negative 12. And now we have to divide by 2 on both sides. So I'm going to go ahead and get, let's use the purple pink one. So we're going to divide by 2, and we're going to divide by 2. And that's just basically saying negative 12 divided by 2. And then this is saying 2x divided by 2. That's why I'm writing this line, to show it's like a fraction. And fractions are division. So this is going to be negative 6 and x. And that's what we're doing here. So negative 6 and x. I'm sorry, my nose is very itchy for some reason. All right. So negative 6 would equal negative x. Negative 6 would equal x. So that's how you show your work. It's really good. This is what happens on a mat. You may have to do this on the test. You may have to show your work from a mat. You may have to show your work from an equation or an expression. So be prepared for all that. All right, let's move on to the next problem. So now we have this problem. I'm going to go and move this down here. And so for this problem, we have Aiden was frustrated that he needed to write so much when solving an equation. Oh, I don't want to write every step and rewrite the equation and do all these things. So we came up with a shortcut. And this is what I do. If you notice what all my work that I've been doing is here's a shortcut. And so here's what he did to solve 2x plus 4 equals negative 12. And you don't want to show and write all those words out. You can do this. So the first thing here is, what legal move does writing negative 4 twice represent? Well, here, this is what it does. It is showing subtracting from both sides, which is also called removing balanced sets. All right, that's the first thing of writing negative 4 twice on both sides. What legal move does circling the positive 4 and the negative 4, which is right here? What is that move? Well, that's creating a 0. We're creating zeros. And we're creating zeros. We're combining like terms to create a 0, whatever you want to say, but that is what we're doing here. Why did they draw a box around the 2, 2? Well, right here, that creates a giant 1. And the giant 1 basically says any fraction as a number on top is the same as the number on bottom. So for example, 2 divided by 2 gives us 1. And they don't put 1x there, but just imagine there is 1x, so we put a 1 in front, but you don't have to put it. And then we also have this right here. I'll use this purplish pink one. Why did Aiden divide by both sides by 2? Well, he divided by 2, and I'm going to put this right here, in order to get x isolated. All right, so we're going to isolate x, and to find what 1x equals. To find what x equals, and just 1x equals. All right. And then here we go for the last part. I'll go ahead and do like some orange here for E. Check Aiden's solution in the original equation. Is its solution correct? And here is what we do. You take the original equation and plug in your answer into that. So I'm going to go ahead and rewrite it down here. So this is going to be 2 parentheses negative 8. So I'm plugging in my x here because here's my x. Plus 4 equals negative 12. Well, negative 8 times 2, I got to distribute, is going to be negative 16 plus 4 equals negative 12, and that actually is negative 12 equals negative 12. If this is a true statement, then you are correct. If it says negative 12 equals negative 12, which is true, you are correct. If it says negative 10 equals negative 10, that's still true. You're correct. If it's 0 equals 0, it's correct. It's true. That means your answer is correct. So negative 8 is correct. Yes. His answer is correct. All right, awesome. So we're just showing our work and use the colors to match the question. So that's 672. Again, I didn't say this earlier, but pause the video, try to see if you can do this all at once and then see if you are correct. And this is really nice concept. We're going really slow here, kind of fast at the same time too. We're going to go ahead and erase the board. And let's go on to 6-73. So 6-73 says, the method of recording steps in the solution of equation is useful only if you understand what operations are being used. So only if you understand what operation is being used for your equation, Matt. So it says, find the work shown at the right on your resource page. That's right here. Let me go ahead and go to the mouse. There we go. Right here. This is our, I'll put this on the right side. Let's go ahead and erase this board. So here it says, for each step in the solution, add the missing work below each line to show what move is. And this is what I actually see on some of your work. And we're not showing the work that we're doing. You're assuming that I know it. And I want to see it, because if you happen to mess up and you show your work, at least I know if you are doing the right thing or not, instead of just getting it right or not. I mean, obviously you want to get it right, but if you don't get it right, you need a backup plan. And that backup plan is to show your work. And if you get the answer wrong, but you show correct work, you still get points. All right, that's what I want you to know. So the first thing here is, how did they get from here to there? Well, I noticed that we have this 7x and we have this 4, which wasn't here. So what they did was they combined it like terms. All right, they combined it like terms here, and they combined it like terms here, right there. All right, and so how I would want you to showcase that is basically kind of like how I do it. I like to circle my terms. So I'm going to circle this term and circle that term. That shows me I'm combining those terms. All right, so I'm combining. And then I'm going to combine these two right there. And that tells me that I'm combining those terms. Let's go to the blue. So I got this right here. So that's the green. Actually, let me make sure I underline the green here that I did. So now let's go to blue. And what do I do to get down to here? Well, I have the -4 here, but it's not here anymore. So what I do, I added 4 and I draw a line all the way down. So I know that it's separating. This equation separates with that equal sign. So I'm going to add 4 here and add 4 here. That means this I circle means it's a 0. I'm creating a 0 there. Now you can cross it through as well, but you circling it, it's kind of what we've practiced before. And then I have 7x equals 3x plus 8. All right, and then what do I do? Well, I'm going to go use red. And then I have this 3x, and there's no more 3x down here. There's no more 3x. So I'm going to subtract 3x here and subtract 3x on this side. And I still draw my line underneath, so I'm solving vertically. So 7x minus 3x is 4x, and this becomes a 0. And now I'm left with 8. And then if you want, you can show an arrow. I'm bringing that down. For example, I'm bringing my arrow down. This -4 I'm bringing down. This 7x I'm bringing down. This 3x I'm bringing down. You can show arrows as in you didn't do anything and you're bringing it down. All right, and that's okay. You don't need to do everything on one line. So then the last step here is I have this 8 and I have this 4x, and I'm going to divide by 4 here, and I'm going to divide by 4 here. And that means this right here becomes a 1. And I like to do a straight line to show that it's 1 or it's canceling out. But canceling out means 0 usually. I'm not really canceling and making a 0. I'm just striking through straight down, because that also can look like a 1, right? It's just a bigger 1. It's a giant 1. And that's why I do that. And so we have x equals 2. All right, so then we got combined like terms. And then the next thing we did was blue, and then that was add for both sides, which is also adding balanced sets. So add balanced sets. And then we have the red, which was we have the 3x. And so we have 7x. So I'm going to subtract 3x both sides, which means I am removing balanced sets. All right. And then the other pink, which was we divide by 2 both sides. And we're just grouping. We're just finding what x equals. And that's it. So that's 6-73. That's kind of where we're at right now. I hope that was helpful. I'm going to go ahead and erase the board. And we're going to go back to the book. All right. So hopefully this is making sense to you, showing you how to do this work, how I want it to line up. And we'll do some practice problems too. All right, for 4-74, for each equation below, solve for x. Solve for x. And you may want to build the equation on your equation mat. Record your work in symbols using Aiden's method for problem 672. So 672, we did this where we circled and we boxed and we divided. All right, so I'm going to try to do it just like that. And I'm not going to build the equation mat. And you don't need to build the equation mat too much. Just I want you to go ahead and solve it just as is. So I will rewrite the equation. And please follow along as you see it. So negative 2x plus 5 plus 2x minus 5 equals -1 plus -1 plus 6x plus 2. Okay, first thing I like to do is I like to combine and make zeros. Combine like terms, reduce, simplify, make zeros. So I'm going to use my green. I see a 2x here and a -2x, and I'm going to go ahead and cross those out. And then I see these can add together, and that will also add together there. And then I also see this right here cross out and this cross out because they're both equal, right? Those two cross out, those cross. So I'm left with 0 equals, that's going to be a -2. And then I have a +2 here, so that actually crosses out. So that's actually going to be a 0 as well. And then plus 6x. And that's it. I mean, like, that's as simple as it can get. So then what do we do next? Well, we divide. Well, let me rewrite it. 0 equals 6x. And you're going to divide by 6. And you're like, well, wait, it's a 0. Yes, even if it's a 0, it's still a number, and you can divide 0. And what is 0 divided by 6, people? 0. You got nothing. If you got nothing to divide, and everyone gets nothing. And then I'm going to go ahead and box this, and I'll do a strike through so it's a giant 1. This is going to equal 0, so 0 equals x, and that is going to be your answer. All right, that's going to be your answer. Okay, let's go and look at B real quick. Again, make sure you pause the video to try to solve it beforehand. And then we're going to have 3, 4 plus x equals x plus 6. And what do I do when distribution? If I'm not going to write my words, what do? I kind of circle my term and I draw arrows. I show my work that way. So I'm doing 3 times 4. And if you want, you can put a little times right there. 3 times 4, 3 times x. So that's going to be 12 plus 3x equals x plus 6. And now we can actually do some work here. So I'm going to subtract x on both sides because I want my x's on one side. And I'm going to go ahead and draw my line. That becomes a 0. This becomes a 2x. I'll try to put everything back into red so you know where I changed. And then let's go to blue here. And then I'm going to subtract 12 on both sides because I want to get this x all by itself. I want to try to find what x is here. So that becomes a 0. So I'm left with here, I have -6 equals, and then I'll go back to green, 2x. And so now I'm going to use that purplish thing. I have to divide by 2 so I know what 1x is. So this is 1x, right? So then the x equals -3. And that's going to be your answer. And that's it. So how you show distribution, I'd like to do the arrows. How you show zeros, I like to circle with my zeros. How do? I box my fractions and do a strike through so I know that I have a giant 1x. And then that's pretty much it. So hopefully this is kind of making sense to you. I know it's kind of tough, but let's go ahead and move on to our next problem. I know this. Let me pause it real quick and get a sip of water and be right back. Okay, I'm back. I just realized that we've been talking for about 20 minutes. I gotta probably end this, but here's what I would like you to do. I'm gonna take a look at this right now, figure out what I think is best. There aren't a lot of good problems here that I see for homework, but there's a lot of them. So we're not gonna do all those. What I would like you to do is I would like you to do 6-76 and see if you can solve these problems right here. All right, see if you can solve those problems. I know if you have questions about it, you can go ahead and ask me the next day or when you get a chance, and I can go over them if you would like. 6-76 and 6-77. Here, I just want to go over this real quick. If I have 2 x's and 3 1s, what does that really mean? Well, I have 2 x's equals 3. You do the same thing. You want to divide this. So I have x equals 1.5, and another x equals 1.5. So if I divide by 2, x equals 3, 2, which equals 1 and 1/2. That's the value of x. So you can have fractions and decimals. Just want to let you know that. All right, so you're going to go do 6-76, and I want you don't have to build the next question, but I want you to solve, circle your terms, draw your giant ones, all that stuff. And then I want you to go ahead and work on 6-81, A and B. I want you to go ahead and, let's see, work on 6-87, A and B here. And I want you to work on those. And I want you to do 6-90, A, B, and C. All right. Well, I hope you enjoyed that for that homework. Just real quick lesson. If you need anything, please let me know tomorrow or the next day or in an email. That'd be great. Have a great day, everybody, and good luck on your homework.